Hey guys, back for another lesson, and today we're going to get into shapes. We're going to connect dots to shapes, and we're going to continue that tomorrow, but it gets started today. But you, like me, need jokes, so here we go. What two letters of the alphabet contain nothing? MT. MT. That's a good one. What is the center of gravity? The letter V. The letter V. There we go. Okay, so what we're going to do today is we are going to get into connecting, again, dots and shapes. And so I'm going to, again, not a super long lesson here, but get into that. And if you can do dots, you can get into shapes. I'm going to show you how this works. And then in chapter 9, we're going to kind of explain the whole logic, the whole idea behind shapes. So anyways, this is where we ended. So two general types of molecules, but number one, you might want to note in terms of determining the shape, and another word that they use for shape is the molecular geometry. So if you're finding the molecular geometry or the shape, step number one is you're always going to do the dot structure, and I'll show you that. You're going to do the dot structure, and then you're going to look at this thing I'm going to teach you called electron domains. And I'm actually have on the board here a table that I'm going to fill out. And it's probably stuff that you're going to have to kind of understand how it works, but also maybe a little bit of memorization. But okay, the first one is when there's no lone pair. So when there's no lone pair is what we're going to look at as a whole group. So this is where all of the central atom, all the electrons are bonded. There's no non-bonding electrons around the nucleus. So A is always the central atom, and B is the number of bonding atoms, or the atoms around that. So here's first example, AB2. And again, I'm going to do this on the board, and I'm going to write a bunch of stuff on the board. But BeCl2, it's a linear molecule with a bond angle of 180 degrees. So in first year chem, we did some of these shapes, but we're definitely going to extend. Very typical of what we do in AP Chem. So we're going to review some shapes. Linear was one we talked about in first year chem. And then we're going to extend that into some other shapes. But in first year chem, I never made my students have to remember the bond angles. But here you do need to do the bond angle. So the bond angle is 180 degrees. So I'm going to go ahead and do the dot structure. Now BeCl2, Be is one of those elements that is an exception to the rule. Okay, so what I'm going to tell you, and I'm going to show you beginning today and then a bunch tomorrow and Friday, is to do the dot structure. So BeCl2. So Be, remember, Be was one of those that did not, one of those exceptions that did not have to fill its outer shell. And it needed 4 electrons. So then chlorine is like this. So I'm just going to do this the way we did back in first year chem, just connect the single dots. And so this right here is the dot structure for BeCl2. So the first is the dot structure, and then the electron domains. Okay, the electron domains are how many single bonds, and an electron domain could be a single bond, a double bond, or a triple bond is one. So this is one electron domain. So this has 2 electron domains. So I'm going to bring my computer over here, and I'm going to fill out this. Actually, this is something that we're going to work on this weekend and into next week. So see this table here all the way across. So what I've got here is I've got the family, and like the family here is going to be AB2, and it's going to be the only one. And again, we're just going to get started on this today, and then we'll really get into it tomorrow, Thursday. But here's family number 1, AB2. Electron domains. So like I showed you in BeCl2, so again, this has, and we're always looking around the central atom. So this has 2 electron domains. The shape of this is linear. The bond angle is 180 degrees. And like I said, in first year chem, I talked about it. I don't know, Mr. Conyers, Mr. Hodis maybe talked about it. But in here, And here we're going to, and this I know it's kind of a reflection, this is AB2, linear, 180 degrees. And if it's polar or non-polar, examples of this is going to be BeCl2, and I'm going to do here in a second CO2. And polar or non-polar. So one thing that is fun for me, and it's actually something I'm going to have you guys do when you guys come back. We're going to do an advanced Tinker Toy lab, but it looks like this. And so if I were to ask you, remember polar, non-polar. So for the whole molecule, we have a pull this way, but we have a pull this way. Equal and opposite pulls in opposite directions. So equal pulls in opposite directions will cancel out. So what we get here then is we get a non-polar molecule. So this will be NP non-polar, and the hybridization is what our lesson is going to be, really the whole lesson in chapter 9. So this, and again, I'm going to leave this up as we go, so I'm going to leave this up for the next many lessons in a row. Okay, so the next one, quickly going back to the notes, is CO2. So again, to me, the key here is to do the dots and then count the electron domains. Okay, so we just did BeCl2, now CO2. So I'm going to do CO2, the dot structure for CO2. So remember CO2, the dot structure for CO2. So here's the old way we used to do it. And we pair up the single dots. So what we get in CO2 then is we get carbon with a double bond here and a double bond here. Okay, if we do it the new way that I taught you, CO2, so we count the valence electrons, so I get 4, and then 6 times 2 is 12, so I get 16 total dots. Well, if I do this, okay, so here's the way, the new way that I just taught you guys in this chapter. If we fill the octet of everything, count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Only get 16. And remember, I add or I remove off the central atom. So now I'm at 16, and then we get the double bonds. So really, whichever way makes more sense to you there. But this, again, goes back to this family. Okay, this is AB2, so it's got a central atom and then 2 elements around it. It's got 2 electron domains. So a double bond counts as 1 electron domain. Okay, so there's 1 electron domain and another one. So it's linear. It's 180 degrees, the example, and it's non-polar. Okay, so there's first grouping. Okay, so now the next one. Okay, so here's the next family, AB3. And BF3 is an example of that. And again, we got to know the names of the shapes, and we got to know the bond angles. So BF3. So like I said, the first thing we're going to do here is we're going to do the dot structure. And you remember there was three elements that were exceptions to the octet rule. Beryllium in the last one was one. Boron is another. Okay, so if I go over here then, so back here. So here is okay, so you guys can see that. So let me erase this. So we've got so if I do the dot structure for BF3, so I'm going to do the dot structure for BF3. So boron, and then 3 fluorines. So again, the whole point of dot structures is then to figure out, okay, how many electron domains? So if I clean this up a little bit, it looks like this. And again, boron is one of those exceptions. So this has 1, 2, 3 electron domains. So AB2 is the only one that's going to have 2 electron domains. Now under AB3, there's actually going to be another one that's going to go here. It's going to be called AB2E, which I'm going to get to in class probably on Thursday. So let me get out of the way. So there's going to be 2 that are going to, and they're both going to have 3 electron domains. So again, do the dot structure, count the electron domains. So if I do that, and I'll do that here in a second. So the shape of this is called trigonal planar. Okay, and this one here, AB2E, is one I'm going to talk about when I start talking about that. This is not that. It's in this family because it's got 3 electron domains, but it's going to have a different shape, and it's something that we're going to talk about. The bond angle here is 120 degrees. Example is BF3. And if I build this, and again, ask ourselves, okay, do the poles cancel out here, or do they add together? If I build this, it's truly like this. It's truly a flat triangle. So we have a pole. We have a pull up, we have a pull this way, we have a pull this way. Equal and opposite pulls in the same direction. That means this is non-polar. So when we have this shape, it's going to be non-polar. Okay, and again, this AB2E, we're going to come back to on probably on Thursday. We're going to get to. Okay, a little bit more. Okay, so the next shape. Okay, so the next shape, and this will be the last one we're going to do, is ABCH4. This is, and really the ones that I'm doing here are ones that we did in first year chem. So again, I'm going to do the dot structure. I'm going to count the electron domains. So this is going to have 4 electron domains. So AB4, example of that is CH4. It's tetrahedral and it's a bond angle of 109.5. Okay, so let me just do this one and we'll stop, and that is where we will pick up tomorrow. But again, if I do the dot structure, and again, everything kind of centers on electron domains. 2, and again, this one we're going to come back to now under AB4. So if I do the dot structure for CH4, so CH4 looks like this. So here, 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 here. So if I clean that up, this is actually the gas. It's called methane that comes out of the gas jets when we light the Bunsen burners. But if I count the electron domains, it's 1, 2, 3, 4. So this has 4 electron domains. Now I'm just going to tell you for the sake if you're following this, and again, we're going to work on this, but under this is going to actually be something we're going to talk about later, but AB3E and AB2E2. Now again, what this means, A is the carbon, and the B4 are the 4 hydrogens around it. So the central atom. So this is going to have 4 electron domains. And so the shape of this, Mr. Wood's kind of bummed you guys aren't here. He's really bummed, but he's able to play with his Tinker Toy. So if you guys can see this, this is the tetrahedral shape. And this is going to be kind of hard to see it, but all the poles will cancel out, which means this is also going to be a non-polar molecule. So this is called tetrahedral. The bond angles are 109.5. Examples are CH4, and it is also nonpolar. Okay, so again, hopefully you guys are watching this, but tomorrow we're really going to get into, let me just step out of the way. And these here, I'm going to leave these blank, and we're going to come back and we're going to fill these in. But these are going to also have 4 electron domains. So the shape is going to be determined by electron domains. All those shapes are shapes that we have had before. And we're going to get into some new shapes on Thursday. So, okay, guys, hey, I will Google Meet with you guys tomorrow. Bye.